So let's start out by saying that this is for a 134A. I do not recommend it for R600. R600, I would recommend one of the other programs, and the one that I like the best. Some people will tell you that they prefer a different method, but I like the lock room method. Just as that, and that's my, that like everybody says, what I do, it may not be may not work exactly great for you. So just remember that even lock ring can be used on 134A. You still have to recover it, just like R600. You don't have to recover, but you have to vent it out into the outside. You can't just drop it into the kitchen. This is highly flammable for an R600. So 134 is a hydrofluorocarbon, and it doesn't it requires for you to recapture it. According to the EPA, all hydrofluorocarbons have to be recaptured. Okay, so one of the things that we need to talk about at the very beginning, you need to make sure that you actually have a compressor issue. A lot of the times it can be something different than the compressor. Okay. And I have seen it where a technician goes out and puts the compressor in, and lo and behold, it doesn't fix it. So he had a different problem. It could be a plugged capillary tube. It could be something different, but you need to know that it is a compressor issue before you go to all the trouble to take and replace the compressor, and then that not be what it is, and you have to spend more money on it. And the customer is not happy at all. So one of the things that you're going to need is, a multimeter, an amp probe. I prefer using one that is a multi/amp probe, a multimeter/amp probe. That will do everything that I need it to do. I have a decent one of those. It's about cost me about $150. This is your livelihood, so don't get cheap on it whenever you want to do it. Find something that works for you. I started out as a technician. I started out with a 1995 meter. It was just your basic cheapo meter. Then I decided that this is what I wanted to do for a living, and I upgraded, and I keep going and keep upgrading my tools. So just, you can start out with a basic multimeter. An amp probe is great. You can do a lot of things with just a multimeter. The amp probe you need if you're going to check for amps. Pardon me. We're going to need some assorted hand tools. You don't have to have a cordless drill and assorted bits. You can do without them. You better be young, because as I've gotten older and my hands are not as strong as they used to be, it's great to have that cordless drill and me be able to quickly remove the screws and the nuts. So that's what I'm going to need basically, is my hand tools, my assorted meter, my meter, and my cordless drill and the assorted bits. Okay. So what are the most common compressor issues? Okay. Usually it starts out with an overload failure, or usually a lot of times whenever there's a power failure, it will go off, and then if it comes back on, like it's a quick on and off, it will trip it has enough time that it's been sitting there for a minute or so, and then the power comes back on. Well, your compressor is not settled, and it will go off on the overload. Okay. What else could there be? Not only could it be the overload, it could be the relay. Okay. Could be the start run relay. So it could be the start winding itself. I've seen it where it took a lightning strike in the house and it just fried everything in the compressor. A locked rotor is an option. Compressor just totally failed. Like I said, with that, whenever it took the lightning strike, it was a total mess up with the compressor, and I also had to replace other parts. Okay, so what exactly does a compressor do? Okay, I'm sure that everybody has a good general idea of what the compressor actually does. Okay, so when it comes out of the compressor, you get a low pressure vapor. Okay, as it goes into the evaporator, into the cooling coils. Okay, it's going to wind into the cooling coils. As it goes through the cooling coils, it's going to be left, and it's going to be a low pressure liquid. Okay, so we're going to go from a vapor to a liquid. Okay, it's going to then go through the outside. It's going to enter the condensing coils. It goes into the condensing coils as a high pressure liquid. As it goes through the condensing coils itself, it's going to come and end as a compressed hot vapor. Okay. So here's what the inside of a compressor actually looks like. I don't know if you have ever seen the inside of a compressor. If you haven't taken one apart and you have the ability to do that, I would encourage you to do it so that you have a total understanding of what the actual compressor does. Okay, so here it comes through to the compressor. Okay, it comes in from the suction side, it goes up, comes down to the suction valve. That valve opens when that piston pulls it out. As that piston comes down, it at one point it will stop. The suction valve will close. The discharge valve will open, and it will charge it through the high pressure side. Okay, so we talked about things that I need to check before I can condemn a compressor. So here's what I'm going to do. I'm going to come to this usually it's on either the left or the right side of the compressor. Okay. And I'm going to pull the cap that houses all of the components, the start components and the overload in the compressor. Okay. This is something that you're going to have to unplug the unit. Do not ever do it when the unit is on. Okay. You have to unplug the unit to be and do this. If you don't, you're going to end up with a shock and hurting yourself. Okay. Here's the components that are inside that little box that I just showed you. Okay. There's one or two types of overloads. Okay. The one on the left is a solid state overload, and the one on the right is just one of the old manual overloads. It actually is spring loaded. Okay. If you look at the solid state overload, there's a little piece right in the center of that overload that is silver. That slides on to the compressor itself, and then the start relay slides on. If something happens and you have one of the older ones, okay, usually that is tucked away inside that little box. You're still going to have that same that same overload is going to be put onto the compressor itself. Okay, so here's how it's sitting right there. Notice that the overload is sitting at the top. Then the one wire is connected to the overload, and then one wire is connected to the start run relay. Okay, this is 200. This is 120 volts. Be sure that you understand that that's what you're supposed to be getting. Okay, so this is just a little quiz that I started. This one I haven't even really gone through this, but we're going to quickly go through it, and I'm going to tell you what it is and why I chose the things that I chose. Okay, so actually, your compressor does nothing but it's basically a heart. All it does is just like the heart in your body. Okay, it beats as it moves through. It pushes the blood through the body. Okay, it goes through the lungs, it goes through the kidneys, it goes through every part of your body into the bloodstream and back. Okay, and then it comes in one side of the heart, goes all the way through the body, comes into the other side of the heart, and you got the same action as you do with the compressor. So instead of it saying that it's like the heart. Okay, it's not like a kidney. A kidney filters. So does the liver, and then your lungs are actually what you have to be able to breathe. So before changing the compressor, what should you look for? Okay, and I always tell new technicians, don't assume that it's the compressor. I need to go look at several things before I ever think that I'm going to need the compressor. Okay. One of the things that I'm going to do is I'm going to check the evaporator coil. Okay. Whenever I first get there, and my complaint is that it's not cooling. The first thing that I do is I open the freezer door. I look for frost on the back wall of the freezer. If I have frost on the back wall of the freezer, I don't have a compressor problem. I probably have a defrost problem. Okay, so I'm going to then shift gears and move away from the compressor, and I'm going to have a defrost issue. Okay, if that is not the problem, I'm going to pull the toe plate. Okay, if I pull the toe plate on the bottom of the refrigerator, some of them are on the top, and I look and that thing is just totally clogged with pet hair or something's obstructing it, I'm going to remove that. That will cause the problem of them thinking that the compressor is not working. So you're going to have to clean all of that off. Most of the time you're going to use your wet dry vac. I used to have a coil brush that I kept with me just to help me reach all the way through to get to to get through it. Okay. So I'm going to look for both of those. One of the other things that I can do is I can pull the refrigerator out. If I'm going to pull the refrigerator out, what's the first thing that I'm going to do? I'm going to put down floor protection. If I don't put down floor protection, I am going to destroy a floor sooner or later. Okay. I have got to make sure that I am going to protect the customer's home. Otherwise, they're going to expect you to pay for it. And I don't know about you, but I don't want to pay for something that I'm not getting any use out of. Okay. Whenever I pull that out, I'm going to look on the side and I'm going to look for a frozen suction line. Frozen suction line can be that my problem could be that that it's been overcharged. If somebody's been there before you, you could have an overcharge. You could have an undercharge. So I can reach as I'm pulling the refrigerator out. I can reach and look and feel for the heat. Almost every single refrigerator today has a mullion heater. Okay, and the mullion heater is used as hot gas that runs through it to keep any moisture off of the outside of the refrigerator. Okay, if you look on the bottom diagrams, okay, this is actually upside down. Most of the time, the common is down on the bottom, is up on the top. Then you have the start, which is the right side. Then you have the run, which is the left side. So that's what's the out of your compressor, what the compressor looks like. Okay, so the one that has the C, that's where that is where a common ground. That's the common wire that goes from your compressor that comes back to the board, or 120 volts. That's the neutral to it. Okay, the hot side, the one that has the power running to it, is the start. Okay, that's where that other one is plugged in. If we go back to this one, so you see the one here on the bottom is going to be your power. The one on the top is going to be, your common. Okay, the overload holds the common. The power wire goes to the start. Okay, so one of the things that I can do is I can check this relay. Okay, this is an old style relay. This is one of the old style relays and not one of the solid state relays. Okay, so one of the things that I can do is that I can go, all right, between points 1 and 2, which are detailed right there. Okay, if I don't get any continuity through there, I'm going to then move to where 1 and 3. Okay, I'm going to go from 1 and 3. If there's no change, I'm going to repeat to step 1. Okay. If the relay, then what I can actually do is I can turn the relay 180 degrees down so that it's down on the bottom, and I can check those same wires between 1 and 3 and see if I have any continuity through there. Guys, I apologize. It would appear that I am not working. The program is not working correctly. It seems like we're having an issue. I see myself fading in and out. So I apologize about that. So this is what a wiring schematic for the refrigerator compressor looks like. Okay. As you say, here's your thermal protector right here. Okay. That is the neutral side that goes to the thermal protector. Then that goes to the common wire on the compressor. We have the start and the run. Then if you look down here on the bottom, that's going to be your power wire. Okay, that goes into it. Your relay is going to be plugged into the start winding and the run winding. Okay, as you can see right here, if I'm going to check the compressor and I think that I have a bad compressor, I'm going to check it. Okay, I'm going to go between the common and the start. I should have it somewhere between 3 and 11 ohms. And then I'm going to go between the common and the run. I should have somewhere between 1 to 5 ohms. Okay. Any compressor pin and ground, if I get infinite resistance or open, what does that tell me? Okay. If I have that problem, I'm actually going to, if I show anything, okay, any one of those two, if I get anything other than infinite resistance or open, I'm gonna have a problem with it. I'm gonna have to take a further check on the compressor. Okay, with an inverter compressor, you are going to go between any two pins. You're going to read somewhere between 6.2 and 11 ohms. This is on an inverter compressor. Okay, I'm going to stop right here. Does anybody have any questions before we move on? I'm going to give you a few minutes here to talk. And that gave me a chance to get a drink of water. Okay, we're going to get back at it. Okay, what tools are needed to replace the compressor? There are two ways to change a compressor. The old way is the torch and solder. With the new refrigerant, RH600 is not a good method due to the flammability of the refrigerant. Okay, a better choice is the new lock ring way. Okay, we'll be viewing the torch and solder method. We're going to go back and we're going to mention it at the very end of the program. So everything from now on is going to be the torch and solder method. Being an old technician, okay, here's the alternative method. Okay. So what am I going to need to replace the compressor? Okay. I'm going to need a set of pinch-off pliers. If you look down here on the very bottom, there's a pair of those pinch-off pliers. Okay. I'm going to need a system evacuation bag or pump and tank. Okay. People don't, evacuation bags are not the norm nowadays. Back in the 90s, they were fine. Everybody used them and then sucked everything back into their recovery tank whenever they got outside, because a recovery tank and the gauges and everything else that you have to bring in, that's a lot of items. You stand the risk of damaging the customer's home. So that's whenever we started using the evacuation bag. Okay, I'm going to need a set of gauges. I'm going to need a set of shutoff valves. I'm going to need a vacuum pump. I'm going to need assorted fittings, both to put onto either the compressor or one of the compressor lines. Okay. Once I've got the assorted fittings, I'm going to use the plier type evacuation tool. And then I'm going to use some sandpaper, some flux, some silver solder, a mirror, a leak detector, protective glasses, and then a flashlight. So that's what I'm going to need to replace a hydrofluorocarbon compressor. Okay. Before tapping in the system, what you should do. Okay. Number one, I'm going to evacuate the system using the evacuation tubing or a solder valve. Okay. Pull the charge into the refrigerant, into the recovery system if it's anything except for an R600. You cannot, if you use the R600 and you pull that into a 134A tank, you've got a problem. You've just contaminated all of your refrigerant. Okay, so let's talk about the flames that we're going to have on our torch. Okay, there are basically three types of flames that you're going to use that are you're going to see when somebody starts a torch up. This is an oxyacetylene torch that I'm talking about. Okay, a carbonizing flame is exactly what it says. Whenever I go and I'm starting to adjust my torch, that's what I'm going to get as a carbonizing flame. If I try to solder, weld, do anything with this, all I do is get a whole bunch of soot. Okay. The neutral flame, that's where you're going to use, that's what that's the flame that you're trying to get to. Okay. An oxidizing flame, again, I can't weld or solder with this. Okay. These are the types of gas flames that you're going to create with an oxygen acetylene torch. The one at the carbonizing flame there, that means the wow, I just lost my whole train of thought there. The carbonizing flame is going to be the acetylene is right here, and that's where you get all of the soot. The oxidizing flame is the oxygen's turned too high. Okay. Where should the tip be located when you're soldering a joint together? Okay. This is a MAP gas torch that is shown right here. And with a MAP gas torch, that's where I want my flame to be. Okay. This is mainly used for plumbing, but you can use it to, you can actually solder with it in a regular uh, in a regular refrigerator. Okay. This is not the flame that you want. This flame is too far away. I will never get it hot enough to melt the silver core solder. Okay. This flame it will never work for a problem for a this flame will not work properly for the flame that we need to solder with. Okay. There is your flame that you want to have. Okay. You notice that all these are on plumbing fixtures, but they work the same. Okay. That's the flame that you're looking for. Your flame needs to be just barely touching. Okay. Where's the hottest part of the flame? Okay. In this picture right here, the very hottest part of the flame is right where the guy's finger is. Okay. That is the hottest part of the flame, where there's a little bit of the of it. Okay. So here it is. If I'm trying to get this solder to flow, where am I gonna concentrate my flame? Okay. As I put these two pieces together, I'm going to concentrate my flame to be on the bottom side of this joint to make sure that this flows down instead of trying to suck it up. Okay. So that portion of it right there is exactly what you're trying to do. If you look, he's just about at the soldering point. So it's about to roll that solder through the joint. Okay. So this is the correct one right here on the left side. The one on the right side, you see what it does. Look at the difference between the flame on the left and the flame on the right. Okay. When trying to solder using the flame on the left, whoops, that was interesting. What will happen? Okay. Do I get done quicker? Yes, I do. Do I save on the gas in my torch? Yes, I do. What's the other benefit? I'm not heating it as long. I have less chance of rupturing something inside of the unit. Okay. I reduce the amount of oxides that are entering into the system. Okay. If I'm in and out, I make it very quick. And so the answer is all of the above. Okay. I had a friend, and this is what happens. If you notice, there is no blue flame in this whole section right here. That's because that blue flame is way away. So there is you're going to get it to look like this right here, and you'll have leaks everywhere. There is no way to get this to seal up. This is whenever if you're brand new and you don't know what to do, this is how you're going to probably start. Okay. This is a YouTube video. Okay. I would tell you to go and spend a little time watching this. If you're new at this, definitely go ahead and type this in, and it'll pull you up a video of it. Okay. So, excuse me, as you can see, there are different things that you can use. Okay. The one on the left is an oxygen acetylene torch. You notice it's for the bigger material. So that you can use that to cut stuff with also. Okay. The one on the right is an acetylene torch. Okay. That's the one that I carried around whenever I was first starting out, was an acetylene torch. Okay. The one on the far right is a MAP gas torch. And I like this little new thing because it actually makes it a little better for me trying to solder. Okay. What's the difference between brazing and soldering? Okay. This right here is a great YouTube video. I would try to bring it up, but every time I try, I have problems with getting it to cast over to our class here. So that is, I'm going to give you a minute to write that down. And that's, you're going to need to go and watch that. Okay. I meant, does it matter if use any pins on the inverter compressor? On the inverter compressor, you go between all three. I check all three of them. So I go between the common and the start, and the common and the run, and then the start and the run. Okay. Brazing copper to copper. Okay. This is another video that somebody has put out on YouTube. I am going to get into my my bag and toolbox, and I am going to do some videos for Encompass University. So stay tuned for those. Right now, these are the ones that I use that are very good videos. Okay, a brazing copper to aluminum. This is a very tricky. Okay, the aluminum is light, and you will actually burn a hole in the aluminum before you get the copper hot if you're doing it incorrectly. One of the guys that I trained, he had a really bad problem of brazing copper to aluminum. Okay, then the last one is brazing copper to stainless steel. You have to do this on every single compressor that you have. There's a copper to steel connection. Okay. So before I tap into the system, okay, like I said, we've got to evacuate the system. Okay. Please don't just start cutting tubing. One of the technicians that worked for me for a day and a half cut into a copper tubing, and I had to let him go. That's a $10,000 fine on him, and I can lose my business license. You have to make sure that you're doing things properly, okay? When soldering copper to steel, it is important to heat the copper joint first because it gets hotter faster. True or false? What do you guys think? Somebody put an answer there. What do you think? If I'm heating copper to steel, okay, am I going to heat the copper first, or am I going to heat the steel first? Which has a higher melting point, copper or steel? Steel has a higher melting point. So what would I do? Yep, you're right there, Impala. You are exactly correct. Okay, so Where should the flame be located when trying to solder? As far away as possible, as close to the joint as I can get, just at the blue, as the blue cone enters at the just at the blue cone as it is the hottest part. So what do you think? Where do I want the flame to be located? We already touched on that, so everybody should get this one. Where's that flame? Where am I going to put it? What do you think, Robert? That's correct. You guys are correct. Okay. So, excuse me. So on the next question, what is the name for the fitting that must be removed after recharging the system? Oh, I have my sister on my mind, evidently. Okay. We did not go over this. But if you look at it, you should be able to figure it out. It should be is it a flux capacitor? Is it the Schrader valve or is it a copper valve? I'm going to tell you it's a Schrader valve. Okay. The other two were fake. Why would you not use a torch on a refrigerant that has R600 in it? We talked about why we don't use a torch. Somebody hit that one. Give me the right answer for that one. That's correct. It is flammable. Everybody knows that this is basically a butane lighter, right? That's what it is. Okay. So this right here is the way that you have. This is what you have to have if I'm going to go inside a home and I'm going to recover refrigerant. Okay. This is what I need to have with me. And the one thing that's missing off of this, that is not a tank. Usually it's a 30-pound tank that I'm dragging around with me. So I used to bring in my vacuum pump, my gauges, and my 30-pound tank in one time. Then I would bring in my torch. With my torch, it was in the back side. I can fit all of this other stuff in it. So I'll take the torch in at one time. Okay. Then I go out to the truck and I get my little bag, and everybody made fun of my little box because it basically was a cheap Plano tackle box. Okay. And in that tackle box, I had all of my fittings. I had my pliers, my crimping tool, my Schrader valves. I had my stay flow, and then I had my silver solder. So that was 3 trips that I had to make to the truck. Not only did I have to have it coming in, I had to have it coming out. I have to take it all back with me. Okay. So you can see one of the things that I like about, one of the things that I really like about the lock ring system, I don't have to bring all of this in. I don't have to bring in the torches. I'm going to have to bring in the tool and the fittings that I'm going to need. So I'll take those with me. I'm going to have to have I'm going to have to have the set of gauges, and I'm going to have a line that I can run to the outside so that outrun it out through a window, but that's a whole lot less than what I'm carrying right here with the old way. Okay. One of the things that I want to talk to you about as you get to be better with a torch, okay? there are three different tips here, okay? One, you can use the bottom, the one on the bottom that goes for just an acetylene torch, okay? The one on the top there on the left, it can be either an oxygen acetylene torch or it can be just an acetylene torch. Okay. Also, the one on the bottom is the one that I was telling you that you could actually use for MAP gas. They make a tip for MAP gas that is very similar to that. It looks exactly the same, and you can use that to solder. The one on the very right is the tip that you get whenever you buy an oxygen acetylene kit. That's the tip that you get. One of the great things about having the torch tip that is on the top on the left is that they make that one because if you look at the two tips, you can put that in there, and I have a better chance of flowing my silver solder properly. Okay. The one on the right, I can use that, and I can even cut metal with that. I have literally cut part of a fender out with that. Okay. So you need to starting out, I would tell you to use just a regular acetylene torch. If you feel comfortable and you think you're good with it, and you become proficient at it, I would jump up and use an oxygen acetylene torch. It is much faster, but I have a whole lot more damage that I can cause with an oxygen acetylene torch. Okay. This is all I would have to have if I'm going to bring in, use it on a hydrofluorocarbon system. This is all I have to bring in. Okay. This tool does come in a huge case, and it has a whole bunch of fittings with it, but it really, all I got to do is have 1, 2, 3, 4 fittings, the pinch off pliers, this Schrader valve tool, and then the lock ring tool. Okay. Does anybody have any questions? We kind of ran through this. I was trying to get everything done. So I'm going to open it up for questions. What do you guys type into the comment box? Do you see the viable usage of the lock ring tool or one of those others that doesn't require you to have an open flame inside the house? Because you always run a chance of melting the back of the refrigerator. I've seen that happen. I had a guy drop a piece of silver solder on the floor, and it was a laminate floor. So I had to have a guy come out and fix the laminate floor. And the customer wasn't satisfied with that, so I ended up having to replace the flooring. That's one of the problems that you're going to find that you have. Okay. Have you used I am unfamiliar with a TUR, a turbo torch. Is that what you're saying? Yes, I have used a turbo torch. That's just the acetylene torch. That's what we called it whenever I was coming out. Was the turbo torch was the oxygen acetylene torch. I mean, just the acetylene torch. Like I said, the turbo torch. I have a MAP gas because MAP gas is a little hotter than just regular old propane. I like. It depends on what you're using it for. If I'm soldering fittings for inside the house for plumbing, I use my my regular MAP gas torch or my oxygen acetylene torch. I mean my turbo torch. I don't have a good oxygen acetylene torch anymore because I have moved so much in the past 3 years that I got rid of my oxygen acetylene torch, because if you move and don't do it yourself, you have somebody else move you, they will not carry either the bottle of oxygen or the bottle of acetylene. So you have to turn it back in, and it was just a pain in the neck. After the second time I moved, I just left it with one of the technicians that I used to have working for me. Did that answer your question? As lock ring gets more popular, yeah, the fittings will come down. But just like I said, I mean, you kind of build that into the price of what you charge to replace a compressor. I have to build in one out of 10 where there's something that goes wrong, and I have to buy a floor, or I have to buy something else, something that I have to do differently, and it's not an in and out kind of thing. I actually talked to a gentleman that said that he pulled, and I don't want to do this, pulls the unit out all the way out of the house and does his work there, and then pulls it back in. I never want to do that. I run such a risk of damaging floors, walls, everything. But I do like it. Okay, so I've got this question. People don't realize that about 30 to 40%, okay, of the oil that's in a compressor, it absorbs R600. Sooner or later, you're going to have a flame out. And there are, if you go out on the YouTube, there was a guy with GE that as a don't do this type deal, he shows you why you don't use a torch on R600. I know guys that say, "Hey, I've used it 20 times." Well, you know what? It may be the 21st time, or it may be the 121st time. Sooner or later, you're going to have a problem, because it is nothing more than a Bic lighter. I would encourage you, go out and look on YouTube and find that video. That thing is scary about what happens. I mean, if the guy had not have known what he was doing and what blows up, it's not good. I mean, he probably would have lost fingers. So does anybody else have any questions? I'm going to put my glasses back on. I'm sorry. I'm 63, soon be 64, so I have a reason for not being able to see. Plus, I've done a whole lot of compressor jobs. Always use, if you're gonna use oxygen and acetylene, please wear your goggles. Wear your safety goggles. Okay, that's the reason my eyes are so bad. Okay. Anybody else? Well, this is running a little short, but I wanted to thank everybody. I'm going to give you an extra hour in your day.